All right, Unit 5, Lesson 2. Okay, so multiplying a polynomial by a monomial. So this is really just distributive property. Okay, a lot of you might know what that means. You're going to distribute monomials to polynomials. So let's get into this example here. So we have a 2 times an x plus 1. And so, in terms of distributing, you have 2 times x and 2 times 1. So that gives you 2x plus 2. In terms of visual, how it works is this times this gives you one of these, and then these two give you 1 and 1. So you can see I have 2 x's and 2 units. Okay? 2 x's and 2 units. Okay, the second one's a lot bigger in terms of the algebra tiles because you're going to be doing an x times an x, which makes a what? An x squared. So we're going to have a big x squared here. And then I have here, here. So you got x times x squared, x times 3, 3x. So you can see that we don't have any units in this answer. I know my note drawings aren't great, okay, but we have x squared, x, and x. They're all x's. Okay, there's no just single units. And that's because why? Because we distributed a what? An x. So the x hit everything. Okay? All right, and the last one there, a negative. Okay, and then in terms of shading, so these, saved it. Thanks. Okay, in terms of shading, these would be shaded, and these would be shaded. Everything's dark on these because everything's positive. Now we have to deal with the negative. So I have a negative times a positive, negative 3x. Negative times a negative is a positive 3. I say negative times a negative. I know it says minus 1, but treat that as a negative 1. Okay, and then in terms of your algebra tiles, positive times a negative, that's going to be a negative x, negative x, negative x. And then positive 1, because it's a negative 1 times a negative 1, 3 times. So we have positive 3 1s, negative 3 x's. Any questions so far? Probably pretty basic so far. Okay, so then right here on D, 2x times x, 2x squared, right? Because x times x, we know that from our exponent rules. 1 plus 1 is 2. 2x times negative 2, negative 4x. All right, visually, I have my 2 positive x squareds, and then a negative times a positive. I'm going to get my negative 4x's here that are white. All right, and this one. So really, you can put the 2x in front if you want, but you can always distribute the other way too. Okay, x times 2x is 2x squared. Negative 1 times 2x is negative 2x. Doesn't matter how you do it. Just will come out the same way. So I have 2x squared, so you can see I have 2 big x squareds here that are both positive. And then I have a negative times the x's, so I have negative x's. So I have positive 2x squareds, 2 negative x's. Questions or concerns with that? No. Sorry, boring. Okay. Example 2, each diagram below illustrates the result of a product of monomial and a binomial. So now I want you to work backwards. Okay, so what do we know? If I have x squared, what do we know has to be in both of them? An x, good. And these are positive, so is it safe to say up here is going to be a positive x? And I know I'm going to have another positive x. Okay, well, what's this mean? I have another what? Another positive x, and a negative 1. Good job. Okay, so I have x and 2x minus 1, yeah? Good. You guys got that faster than I did the first time. I'm not an algebra tile guy either. I never really used them, so. Okay, this one here, ways we can do it? Yeah, there is 2 different ways we can do it. So yeah, negative times a negative, and then a positive here. So that's your 2 options you can have. Okay, and this one would be negative x times negative 2x plus 1. Just worry about that later. Focus on what's at hand. Okay, all right, and so state the polynomial represented in each of the diagrams, and so we did 2x squared minus x is what the pictures were, like the answers. So let's complete the left side diagram, write the polynomial product, and that's where we wrote x times 2x minus 1. Okay, and then on number 2, it said write the other one. That's what we just did as well. Was that? Right, each product as a sum or a difference of terms. Okay, so write each product sum or difference of terms. So we have, like, means distribute them. So this one would be 2x squared minus x. This would be 2x squared minus x. So you get the same thing, is the point. If you want to draw like a little arrow, we're just doing this and just doing that out. Okay, so let's verify the polynomial product in D with x equals 3. So we're going to verify that they are the same. So we're going to put a 3 in. So we're going to put a 3 into here, So I'm going to go 3 times 2 times 3 minus 1 for my first one. And then I'm going to do negative 3 times 2 times negative 3 plus 1. So we're just going to make sure that they're both the same. So I get 2 times 3 is 6. 6 minus 1 is 5. Times 3 is 15, yeah? Okay. 2 times negative 3 is negative 6. Plus 1 is negative 5. Negative 5 times negative 3, 15. So we get the same answer. So we just verified. Okay, good. We got one more page. Everybody good? All right, last page. All right, so then the distributive property. Essentially what we're doing. Okay, we've shown that by distributing this, we get 2x plus 2. By distributing this, x times x, x squared plus 3x. By distributing this, 2x squared minus 4x. Okay, and distributing this, negative 3x plus 3. Negative times a negative. Okay, x times 2x, 2x squared, negative 1 times 2x minus 2x. All right, these are examples of distributive property. Okay, this is the distributive property rule. If you have an A outside signifying multiplication, the A hits the B and the C, so AB and AC. That's all the distributive property is. Okay, so let's move up here a little bit, and then I'll kind of get some input from you guys. So we'll start with like Tatum. So what would A be here using distributive property? Good. Okay, good. And B, Jos? Good. Good. Awesome. Good job with your negatives there. Mike? C? So you're going to hit that x squared. It's going to go through. 3 plus 2. x5. Good. Remember, adding exponents there. Okay, we're adding exponents, not power to power. Okay. All right, Xander, D. Good. Okay, plus, minus, but yeah. Good. Okay, good. All right, so in the example above, we've written the product of the polynomials as a sum or difference of terms. In this process, we expanded the polynomials by using its derivative property. Okay, and we used the exponent rule of product of powers, which is addition, which we learned in Math 9. Okay, Breezy, you want to try class example 4, part A? Okay, they did that to you on purpose. What's your order of operations? Do we subtract or multiply first? Multiply. So we do this last, okay? So you have the -4 goes through first. Got it? Go ahead. So 6. What's -4 times 8? Good. And then what's -4 times 1? Okay, good. Now we combine like terms. So 6 minus 4. And then we have the minus 32x. That's your answer. Okay? That's a very, and Breezy, actually, I'm glad you did that because we can't do that, right? Remember, don't put your order of operations. We have to do multiplication first. Okay? Don't forget that. And your test, I know your book, they always try to throw those ones in there to make you just bite, to do 6 minus 4 real quick. Okay? Don't do that. Okay? Allie, part B. You have to do 2 of them here. Yep. Multiplication. 4 times 3. Yeah, there you go. Okay? And then now, when you have this right here, Allie, multiply a -2 through, okay? So what's -2 times x? -2x. Okay, and then what's -2 times a -6? No, 2 times 6. 12, plus 12, because it's negative times negative. Now, let's put your common terms together. So what's 8 minus 2? 6. And then -12 plus 12. Gone. Yeah, gone. So that's just gone. So this is your answer there for part B. Good? All right. Go back to back there. Chris, you want to try C? Okay, good. Good. Okay, important here, this negative hit both things. That's why it's now minus 3x squared. A lot of people always say just minus 4x and they keep it a plus 3x squared. The parentheses signifies it's minusing both, so they both have a negative. Okay? Another common mistake that I always see. Did everybody hear that? So if the parentheses have a negative outside, it means you have to switch the signs on the inside for both of them. That's why Chris changed them to both to negatives. Okay, go ahead, Chris. Okay, good. That doesn't change. It's the only one. Okay. Okay. And 5 minus 4 plus x. Okay, good. And I like to cross things off as I go. I'm just doing that right now with Math 20s and our rational expressions, just to keep yourself organized and so you don't miss anything. Okay, and one last example here. Okay, determine the simplified expression for the area given the shape. So the best thing to do here is to section it into 2 rectangles. This way? Yeah. Sure. I think you probably could. Yeah, you probably could. Except for, well, yeah, you could. It'd be a little bit, what's that? No, because you still have to find this guy and this guy, so you still have to find 2. Yeah, but we still have to find this length. That length's not going to be 2x. See what I'm saying? Because to find this length, what I have to do? I have to do this minus this. Does that make sense? Because it's going to be 3x plus 2 is the whole thing. X plus 5 is this chunk. So I minus them. So, I mean, you can do either way, Mike, but I think I might go with the long way here. Okay, so this one, this rectangle is 2x times 3x plus 2, right? So 2x times 3x plus 2. I'm going to add that to x plus 5 times what's this? 2x, because this is 2x, then this is 2x. So x plus 5 times 2x. So now we were adding their areas right now. Okay, so that's going to be 2x times 3x, 6x squared. 2x times 2, 4x. 2x times x, 2x squared. 2x times 5, 10x. 6x squared plus 2x squared is 8x squared. 4x plus 10x is 14x. So the area of that figure can be represented as 8x squared plus 14x, excuse me. So now it wants us to subtract the two rectangles. So they want me to subtract these two to get like what this missing piece is. So if I do this guy minus this guy, it'll give me what that missing chunk is. Sorry, does that make sense? Okay, because this one's the bigger one. So we already know that's this one's, we want to go 2x times 3x plus 2 minus the 2x times x plus 5. Okay, so just same thing we have over there, but just minus. So what I'm going to do is, I'm going to steal this, since I already did this work. I'm going to steal 6x squared plus 4x minus 2x squared plus 10x. That's just me. Might be me. Okay. The negative hits both things. So I'm going to go 6x squared minus 2x squared. 6x minus 2x is 4x squared. 4x minus 10x. Remember, it's minus 10x because the minus hits both things. Okay? Negative 6x. That represents that area right there. Let's see here. Yeah. Okay. All right. Any questions? All right, that should work.